So we talked about using CIN to get our input. We've practically been doing that since day one. So we had to wait till chapter 3 to see it in the PowerPoint, but that's no problem. We like to work ahead. What does CIN stand for? It stands for console input. It's a stream. It's an IO stream. So you have to use #include IO stream to bring it in. There are other forms of IO streams as well as CIN and COUT. You can also write to a file using the same syntax. FOUT * X would print X to that file, or FIN greater than X would read in from that file into X. We're not there yet. We've seen that you can use multiple of those to read in your input, right? Let them type in both the height and the width before hitting enter. We demonstrated it, and I'm not going to use it again in this class. Mathematical expressions. We have talked about mathematical expressions. These are the operators, the symbols of the operators. These are what are known as binary operators, meaning that each one of them takes 2 pieces of data. And what does that mean? Well, asterisk is the operator, means multiplication, and the 2 pieces of data it needs are this and this. Those are the operands. So it multiplies 2 by pi, and gets some kind of result. 6 point, I'm going to make something up. And then now there's another operator that has to be processed. It also has 2 operands. It has the result of that first one, and it's got radius. So if the radius was 10, then, it does that math, and it gets 63 or whatever, Then this is an operator as well. It's called the assignment operator. It just copies whatever's on this side and puts it in there. And so when it's all done, that value, 63 dot whatever, would be copied in the area. The order in which the operations are done is known as order of operations. And I know that we've talked about this because I remember regretting that there's no exponent operator in this language or in Java or C#. Very few of them. Python is a rare bird, and I'm glad that it has the exponent operator. I like it a lot.
But now you have to use PW and all that stuff.
Yeah, all we have to do is import CMath and use POW. No problem. No biggie. So when we are mixing apples with oranges, type conversion. Inside the computer, ints can only be multiplied by ints or added to ints. You can't multiply an int by a float inside the computer, in the hardware. And the computer engineer in the room is going to twitch and say that I'm an idiot for saying that. But fundamentally, integers and floating points are different data types. And so one has to be converted into the other in order for cross-type math to happen. You want to add a floating point num to an integer number. The bit sequences for, these are all the other nodes. The bit sequence for 1 and 1.0 inside the computer are completely different. Completely different series of zeros and ones indicate 1 and 1.0. And so if you were going to add 1 to 1.0, they would both need, one of them would need to be converted to a compatible type to the other one. It would not make sense to convert them both to ints. Yeah, in this case, 1.0 could be converted to an int with no data loss. But if you had this, 2 plus 3.5, and the computer, the compiler is trying to provide opcodes, to write out to create the machine language that's going to do this math. These need to be of the same type before the processor will be able to perform the operation. I'll add those 2 numbers together. It would not make sense to convert them both to ints, because converting 3.5 to an int would lose the fractional part. Integer means whole number. And so then it would say, okay, 2 plus 3, now I have 2 ints, the result is 5. We don't want that to happen. So we do not want to take the better data format, the more precise data format, the one that supports floating point and convert it to the lesser type, we want it to go the other way. We want to take this wimpy integer type and convert it to a floating point type so that the math can happen. So what C++ will do is inside itself, it'll provide the code that would take that int and convert it to be a double before the math could be done. Now we don't see that happen. All we know is that if we type in x equals 2 plus 3.5, it magically happens. You know, this math magically happens. That int is converted into a double so that it can then be added to that other double, because the math operators, the arithmetic operators, can only work on data of the same type, and if they are not of the same type, then the data will be converted in order to let that happen. And so it goes up the hierarchy. Ints, you know, can be converted into doubles.
Doubles and integers and stuff like that.
Yeah, Python goes to a lot of effort to make sure that you don't have to worry about any of this. So ints can get promoted to longs, which can get promoted to doubles. So if you have an int and a long, the int will get converted into a long so that the math will happen. It wouldn't make sense to try to turn a long, which could be a huge number, into an int, right? Because if you took 4 trillion and then turned that into an int, it's not a valid value. We've played with that already. We know that it won't fit in there. So ints can be converted into longs. Longs can be converted into doubles. That's called implicit casting. Implicit casting is when you have a data type that needs to be converted into another data type. So promotion is converting to a higher data type, turning a int into a long or a int into a double. Demotion converts to a lower type. That's when you get your data loss. That's when you try to store, you know, some value that's in the trillions into an int and it can't fit in there, and so data gets corrupted. So demotion is something that we do not intentionally do, or if we do it, then we do it with very specifically with something called casting. Overflow and underflow are when the data gets too small or too large to fit into the number of bytes allocated to it. And I just did an hour-long lecture about counting in binary and how many bits are in a byte and the maximum value that you can store in 2 bytes versus 4 bytes versus 8. I can't stomach doing that again, so we're going to not talk about that right now, but we are going to hit that idea after a little bit. Just know that the more space you have dedicated to a number, the larger the values can get, the more precise the values can get, which is why your Super Nintendo and your Genesis worked so much better than your 8-bit Nintendo, because those were 16-bit machines. Then you bought your 32-bit PlayStation and so on. You know, Windows 64 uses 64-bit hardware so that, you know, it can address larger amounts of memory, and the numbers that it can access, you know, are larger. So typecasting is when you provide the method by which you want the conversion to happen. Implicit casting is just when it does it on its own. Oh, you want to add those 2 numbers together? Well, I guess I better convert that one to a double so that the math will happen. C++ provides the code behind the scenes for that. But we could specify how we want the conversion to happen ourselves. We could do this. X is equal to long parentheses 2 in parentheses plus long parentheses 3.5. What we have decided is that for some insane reason we want to take this double and convert it to a long, and we want to take this 2 to a long, and we want to add those together. We're being very specific about the results, how we want it to happen. That's called casting, explicit casting. Now, are you going to normally convert things into a long like that? Probably not. But explicit casting, you pick how the data is going to be converted into another type. So you can do things like this. Int I is equal to int parentheses f. And whatever f is, it will get converted into an int. That's a Python syntax. It works in this language as well. You won't see it in Java. In the C programming language and in Java, it looks more like this. Int I equals parentheses, int in parentheses, f. Both of those methods work in C++. And just to be weird, C++ offers a third way. Int I equals, and then they use this static cast keyword. Static underscore cast angle less than int greater than parentheses I in parentheses semicolon. Hoo boy, that's a lot of typing. Now, if you were going to turn something into a double, you would replace that word int with a double. Or that one, or that one. Or if you were going to change a long, then you would put a log there, the word log, or log there. Right? That's what you would do to convert it into a log. Right? So log L equals parentheses long in parentheses f would convert f whatever it was to a long. I'm not sure how to do long if you do it in this syntax. Or you would do, if you want to convert something to a double D is equal to, parentheses double in parentheses f. That would take f and convert it into a double. Or you could do one of the other syntaxes. Double D is equal to double parentheses f in parentheses. Or thirdly, the long one, double D equals static underscore cast less than double greater than parentheses f in parentheses semicolon. All three of those work.
Wow, talk about typing too much.
Yeah.
Especially if you're a computer science student, and you probably have to do some calculations in programming or something like that. I don't know. I hope not. Everybody help me on the, yeah.
Professor, can you tell me again static?
Just a second.
Syntax there.
Okay, I'm sorry. Pardon me.
Can you explain me the static cast?
I wish I could. If we go and read what the PowerPoint says, it just says that it's a form of casting. The C-style cast is to put the data in that format. The pre-standard C++ cast is to do it in the Python fashion. Both are still supported, although static cast is preferred. So why don't we look up what static cast does? Static cast performs an explicit type conversion. It says the general syntax. We have our keyword there, although they're copying an operator. Inside the angles, you put the type that you want it to be converted to. And then inside the parentheses, you put the data that you want converted. And what I would recommend that you do, if you want to learn more about this, is to Google up static versus dynamic cast. That would be the phrase to Google up to learn a lot more about it. Static versus dynamic cast. And then you'll see some explanations about it. I would look that up. I really can't explain it any further than just to say that, just like we wrote here, it's one of the three ways we have of converting data from one numeric format to another.
Thompson, are we going to do while loops today? I hope so.
Yeah, we could. Not part of the chapter, but that's no reason not to do it. Absolutely we are. We've got a great reason to use while loops coming up. Multiple assignment and combined assignment. If you want, you can do this. X equals Y equals Z is equal to 5, and it will copy 5 into the Z, and then copy that into the Y, and then copy that into the X, And so they're all will wind up being 5.
Why would you want to do that?
You just have a whole bunch of things and you want to set them to the same value. You have 7 variables, you want to set them all equal to 0, A equals B equals C equals Z. I don't really see much of a point, honestly. but it's a valid syntax. And if it makes sense, if you want to set several values to the same value, you know, to start off a loop or whatever, you know that you're going to have 3 variables and you need to start them all off at 0. That's certainly a fast way to do it. X equals Y equals Z equals 0. This is showing off that the equals operator, the assignment operator, has what's known as right associativity. Associativity is the way that things are evaluated. Right associativity means that the 5 gets copied into the Z, and then the result of that expression gets copied into the Y, and then the result of that expression gets copied into X. Now most things have left associativity, left to right. Like if you do this, X equals 1 plus 2 plus 3 plus 4 plus 5, it does that left to right, right? It adds 1 to 2 first. Hey, come back. Right, it does it in this order. 1 plus 2 is solved, and then it gets added to 3, and then it gets added into 4, and then it gets added into 5. Most of your math operators, the vast majority of them do, you know, left associativity. The equal sign, single equal sign, does right associativity. The only other operator that I can think of that does right associativity is not even C, or C++ or Java. It's star star from good old Python. If you have this, 2 star star 3 star star 4, what does that mean? Does it mean 2 to the power of 3 and then calculate that result and then take that and raise it to the power of 4? No, actually not. It means take 3 to the power of 4 and then take 2 to that power. And we kind of know that if we were going to write it down. You know, 2 to the power of 3 to the power of 4 does not mean do that and then take that answer, 2 to the power of 3, I guess is 8, and take that to the 4. No, instead it does this, 3 to the power of 4 first, and then take whatever that is. I don't know what 3 times 3 times 3 times 3 is. 81? That could be. I may have gotten that right. And so anyways, 2 to the power of 81. So the exponent operator in Python and the equality operator, the assignment operator in all these languages are right associative, but usually everything else is left associative. Yeah?
I think that 2 to the square root of 81, that's going to be a big number. And
Yep.
most calculators are not going to handle it.
Well, if we do this, it's 2 to the power of 81. I'm curious. Let's let Google tell us.
Actually, I can calculate it.
Okay, 2.4 to the power exponent of 24. What data type would not be a good data type for that? Ints would be bad. Floats, long longs, yeah, long longs would probably actually work for it because long longs support like up to the exponent of 38, if I'm remembering correctly. I could be wrong about that, but I just use a double to hold a number that large.
That's a big number.
So combined assignment is when you combine the assignment with something else. Yeah, okay, so we're going to take that number, we're going to add something to it, and we're going to store it back into itself. And there's a shorthand for that. And I know that we all know the shorthand. Sum plus equals 1. That's the combined assignment for that. And you can also use minus equals, or multiply equals, or divide equals, or modulus equals. Bless you. So the combined assignment operator is just to put plus and equals together to say, in shorthand, sum plus 1, store back into sum.
Store it back in the
Now there's very specific ones. There's sum plus plus, whoops, and sum minus minus. That's called the increment and the decrement operator. Python didn't give them to you, but you can find them in a lot of other languages that are all based on the C syntax. This just means add 1. It's the same thing as plus equals 1. And that's the same thing as minus equals 1. So plus equals, x plus equals 5 is the same as x equals x plus 5. Z star equals 10 is the same thing as z equals z times 10. Formatting output. What if you wanted your output? What if you had calculated your profit to be 4.5678, but you wanted to print it in the form of profit equals $4.56? This is what you want your output to be. We wish we could get that, but unfortunately our number is that. In Python, there was a way to jigger the print statement to get that to work. In Java, you have printf, which can do the same thing. C#, being a somewhat strange beast, has a very strange way of doing this, but it will work. Why don't we go ahead, and we're going to get to combine while loops in this at the same time. Why don't we go ahead and launch Visual Studio?
Learn more about while loops, because I would like to do for my homework assignment.
And I know I'm going to need the boilerplate, so I may as well be grabbing that while it's going. I believe that I'm going to make an empty project, make it Lecture F.
Just kidding.
Lecture f.cpp. Paste. Alrighty. So, double profit is equal to $1,000, 1032.56789. And then so C out less than quote, congrats, profit equals $ end quote, less than profit less than ENDL. And that's what it says. Way. Magically, it came out to the right number of decimal places. That was not my intention. What happens if I just make a profit is equal to 2.56789? There, and that's what it said. 2.56789. Now that's actually implying something.
What happened here?
It's saying that by default, Cout will display 6 digits of precision, right? So when I changed it to 200.56789, Cout displayed it as 200.5678. But I might want to be able to control that. I might want to just only show 2 values after the decimal point, or I might want all 5. Or I might not want no values after the decimal point. So to get that to work, well, if we change it to int, we wouldn't have any fractions to worry about. You're right about that. But we want the fractions. We just want to display it up to 2 decimal places. And so we're going to include a new header called iomanip. # include iomanip. Wait. # include less than iomanip greater than.
Then
And what I'm going to do is I'm going to specify how many decimal places I want to be able to show. With the iomanip, we can specify the number of digits. We can dictate how many spaces to fill on the screen. If we want everything to line up in columns, let's write a little for loop that does not line up in columns, and then a while loop that does not line up in columns, and then we'll work on trying to make it line up. So let's do this. Let's declare a counter variable. C for counter. I'm going to set it equal to 1. And then let's declare something that we could double each time. X is equal to 1. And let's write a while loop that keeps going, maybe repeat ourselves 10 times, doubling the value of x each time. So C out, wait, while parentheses, C less than equal 10 in parentheses, curly brace. Now what is going on here? I know you already know. But this is just like an if statement, except at the end of the curly brace, it doesn't exit the block. It instead comes back up here and checks again. And if it's still true, then it repeats the block again. And it keeps repeating that block of code until this condition is no longer true. So looping is one of the 3 forms of flow of control, or control flow. The 3 forms are sequential statements, and then branching statements, like if, and then there's another one called switch. And then loops, which can be your while loops, your do loops, and your for loops. Flow of control just means the order in which things are executed. You know what sequential means. One after the other. This is the first line of code. This is the second, that's the third, that's the fourth, and that's the fifth, and they're going to happen in that order. We know what an if statement does. You have an if statement, the condition is evaluated, and it will do whatever is inside the curly braces. A loop does whatever inside the curly braces dependent upon the expression, but when it hits the closing curly brace, it reevaluates the expression. If it's still true, then it repeats it.
Could you scroll back a little bit?
Which part?
That's it.
Up, down, or what?
That's good right there.
Okay. Okay, so what are we going to do? Why don't we double x? X equals x times 2. Now, didn't we just see that there's a short form for that? What would be the compound operator version of that? Instead of saying x equals x times 2, just like if we had, don't type this, z equals z plus 10, we could replace that with z plus equals 10. What can we replace this with? X equals x times 2.
You cast it as x.
No casting. My example here was to, if I had z equals z plus 10, I could rewrite that as z plus equals 10. They mean the same thing. This is called the compound operator, the compound addition operator, the compound assignment operator. It takes 10 and adds it to z and stores it back into z. How could we rewrite this one so that it had a compound assignment operator?
X times equals 2?
Exactly. X times equals 2. And then I want to add 1 to our counter. But I'll do that after we print out our result here. So C out less than, C less than, double quote, space, double quote, less than, NDL, semicolon. And now we need to add 1 to our counter. We could do C plus equals 1. It's what we would have done in Python. But we're even more awesome than that now, so we're just going to do C++. I am going to add a comment to the effect that this is the same thing as x equals x times 2.
C++.
Yeah, that's where it got the name of the language.
So why do we need to change it to x times equals 2?
Just to show. There was no fundamental reason to do that. But this is considered a more professional way of writing your expressions than doing that. Yeah. Something's looking odd, and what I'm thinking looks odd is that apparently I don't have a project I can build and run. Oh, I'd already run it once, that's why. Okay. So here we go. It printed out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that is not what I intended. I forgot something. I wanted to print out the values of x and y. So before ENDL, I need to print out x less than, there.
Wait.
So C less than, quote space quote, less than, x less than ENDL. And I think we already did this once in order to prove data overflow.
Yeah, fine, post file.
So what we're seeing here is the number of times that the data has been doubled, right? And the result of that. Or we could think of it just as powers of 2. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, and so on. What if we had swapped these so that x came first and then c came second? All right. These are kind of looking jagged. They're kind of looking ragged, right? What if we increase the number of times this happens? What if we let it double itself 30 times rather than just 10? We're going to get up to about 1 billion. That's the maximum number of times that we can double an int before we get data overflow and the data get corrupted. But sure would be neat if these were all nicely lined up so that all of these numbers were on top of each other, like in a spreadsheet. Does anybody have any syntax errors right now I need to come look at? Nope, all good? All right, so what we're going to do is we're going to use the width IO manipulator in order to dictate how wide, how many spaces each piece occupies. Set W dictates how much space is dedicated for that. So in front of that x, if I do this, set W parentheses 10, close parentheses, less than. This is what I just added right there. What that says is that the next scene that's coming is going to be padded out to a total of 10 spaces. So if x is only 1 digit long, there's going to be 9 spaces. If x is 8 digits long, it's going to get an extra 2 spaces added to it. And there we go. Looks a lot better, right? So that is one of the IO manipulators. IO manipulators. You have to # include less than IO manip. Set WX sets the width of the next piece of data to be displayed. If you set that to 20, then you get even more space. It'd be silly, but we can. Now what if you don't give it enough space? And what do I mean by that? These numbers get up to 1 billion, which is like 9 digits long.
Put negative numbers?
Good question. I don't even know. But first I'm going to try 5. It padded it out to 5 spaces. But when the data got to be longer than 5 spaces, well, too bad. Right. Then it started looking ragged again. So that set W better be set to the largest that you really want. It's not going to somehow decide to delete some numbers to make it fit within 5. Instead, it tries to pad it out to 5 spaces, but if the data is longer than 5 spaces, it doesn't work. Now let's try that negative like you suggested. This is a test. I have no idea what it's going to do. Nothing. All right, okay. But you may have been expecting it to do left justification versus right justification if you've done other programming languages where if you stick a minus sign in front of the format specifier, it left justifies it rather than right justifies. Now what do I mean by justify? This is all not notched against the right margin. That's right justified. You might want the numbers to instead be left justified. These are left justified because we did not have a set W in front of them. If we had a set W in front of them, they would also be right justified. The width specifier works only for the very next piece of data that's coming. That's why this one's not also padded out to the same. If we want this one to also be padded out to the same, then we would have to call set W again, like this. So in front of that C, I'm going to do it again. I'm going to do another set W. But it only got to be like 2 digits wide, so I don't need to give it 10 spaces to play in. So in front of that C, set W, parentheses, not 10. I said I wasn't going to give it 10. How about 2? Set W, open paren, 2, close paren, less than, less than. So this is the part that I just added right there in front of the C.
Looking key to continue.
So is it like the middle in between both?
Just a sec. And now both of them are lined up on their right side rather than their left. Pardon me?
Okay.
Yes, sir.
Don't do this at any university.
Parentheses.
If anything, I would probably convert that to a long. Let me try doing a long on this one.
It's actually an L.
I just found out today that there's a Blaze Pizza.
Same for that one. It's END L.
I just tried the Blaze Pizza on campus. Yeah. Well, it's not on campus, but it's at least they're 2 away.
The end of file found before the left brace. It just means that we don't have enough closing braces.
You know where
One
Mad
open
Red's
brace. Now there's a second one. And then we have one closing brace. And the second one. Now actually what we're going to do though is we're going to put this closing brace in front of the system box.
I'm gonna set.
I was all like, I mean, listen, USA actually has some good pizza places around here.
Okay, cool. And then the next thing we did is we changed it. Sorry, that was just a test.
I'm not trying
That's
this.
actually the final change.
I only been to.
Let's change that to 30 so that we have more data.
Oh, hold
Works
on.
more
Is
times.
Yeah. Isn't that same shopping center where the Chick-fil-A, where the
Nice. Okay, sure.
It's like a social
Let's change it so that we're printing
Oh,
out.
so it's a,
Well, it's like it's by UCO.
okay. Okay, but yeah, I know I'm just talking about Midwest Stage, you know, I only been to.
Actually, I wanted this
I've been
one to be
Blaze, I've been to
before
the other shopping district where the food district where Ted's is at.
And we wanted to
Your-
print
your
out,
part.
yeah. This
Sure.
is what happens when I make too many changes up there.
I think your pie's closed.
Follow along.
Oh.
Oh yeah, that is closed.
Like closed for good.
Yeah, actually, yeah, you're right about that.
I don't know why
Or like have layers
Okay.
around here, man,
All right.
and then there's this other places on this thing.
Okay, so there is an IO manipulator that'll dictate whether it's going to be right justified or left justified. Yes, sir.
I have a question. So
Uh-huh.
we have a how do we make 2 or 3 same line? I want to make a 2 and 10 is first here.
Well, you want them to be not margined like that, but on the other one. Let's see if we can find an IO manipulator that'll do that.
I had another question.
Uh-huh.
Could we have a completely different data set that was on the left side and the right side too?
Yeah, sure. Whatever you were going to print out, like whether it was a result of a calculation or some array that you were printing out or whatever. We're just printing out 2 columns, and the easiest 2 columns I could think of was to do that number and then the number doubling.
Let me try 20.
Here it is, left. Left causes the output to be left justified, whereas right causes the output to be right justified. So, if I wanted this number to be left justified, I would have to do cout less than set w
Did you print that for me?
less than, sure, right, like that. No, actually I wanted to watch it do left. It's doing right by default. And now, that one is lined up like that. They both are, though. A minute ago, they were both right justified. Now they are both left justified. So if we wanted to go back to being right justified, then we could go over to this one and do right. Exactly.
Thank you.
Sure. So, right and left control whether the data
I think
is
this
right
one's a counter
or left
control
justified.
loop, right?
I'm sorry, pardon me?
Is that a counter control loop or whatever?
That is a counter control loop. You're so right. Exactly, that's a counter control loop.
And I think there's another type of loop. I think it's something control loop.
Well, there's user query, there's counter, and then there's sentinel value.
And we're going to use user query in fundamentals.
Yeah, user query is forgive me for just typing it like this. Please enter a grade, 10. The average is 10. Do you wish to add another y/n? And they typed in y. And then please enter another grade, 20. The average is 15. Do you wish to add another? And you could keep doing that. You could keep doing that until you finally decide to type in no, and then it would say, okay, done. So the user query part is that it's asking you, do you wish to repeat? Okay, I'm sorry, go on.
That might be what we did in programming logic, but I'm not sure.
The other thing, okay, that is, yeah, 3 kinds of loops. Counter loops, counter controlled loops, user query, which is, do you wish to repeat or do it again or something like that? And then there's sentinel values. Let's do an example of a sentinel value, but let's finish talking about the IO manipulators first.
Okay, thank you.
So what we've got going on here is we have seen that this is an IO manipulator, and then we can use right and left, and there's another one. Besides setting the width, we can set how many decimal places we want displayed. Set precision. Set precision sets the precision of the floating point numbers. By default, set precision, by default, cout is supporting 6. I think we saw that at the very beginning, right? did not matter how many decimal places we had in our output. It was going to display 4 digits. It didn't care whether where the decimal point was in there. It was just going to display, did I say 4? 6 different digits. So when we ran it, it displayed 6 places, 200.567, because that's the precision. We scroll up and see that, but we can change that. Let's make it print 7 digits of precision. So we're going to come here, and before we print out that number, we're going to set the precision. We could even do it on the line above. Cout less than, set precision, parentheses, 7. I want 7 digits of precision. Less than, ENDL. And now it's got 7. 123.4567. But that still doesn't handle my dollars and cents business, right? I only want 2 decimal points. Well, you still use set precision, but you modify it to work with something called fixed. So instead what I'm going to do is I'm going to cout, I deleted that entire line by the way, cout fixed less than, set precision, parentheses 2, in parentheses. Fixed means that the decimal point is fixed in place, and then the number refers to the places after the decimal point.
Set precision.
And so now it's looking good. Congrats, profit equals $200.57. So if you're going to print dollar amounts, you may as well just throw that in there. Does that mean that every number is going to have 2 decimal places? Not if it's an int. Notice it didn't change our ints. Our little table, I'm getting tired of seeing that many. I'm going to lower that down to 20.
That's right, it's only his.
I'm losing my voice. Right. These did not change to show 2 decimal points. Why? Because they are ints. They are not doubles. They're not floating point. But if I go and I print out another number for whatever purposes, cout less than, I wish it was $, end quote, arrow, 99.999999.99, right, like that. It's still going to only show it to 2 decimal places. But it actually might show it in scientific notation, I don't recall. Well, look at that. I wasn't expecting that. Okay, maybe I should remove a few 9s. I don't know what's happening unless it's data overflow, and it doesn't look like it should be.
Expression must be integral. What? What?
Oh, I see what's going on. I just didn't have an ENDL, so it wasn't going to the next line. All right. Now I feel much better.
What's going on here?
I'll take a look. Okay, so this is my final answer. I'm going to make it print that. But I'm going to put extra 9s in there just to prove that they have been shortened to only 2 of them. And there they are, right? It got rounded up and is displaying 2 decimal places. It is following the same rule. Once you set the precision continues to be set at the same thing. It's kind of like once you go into this mode, it stays in that mode. A lot of these things follow that. I will get over there. A lot of these things follow the same rule. Once you set it to be right justified, it sticks in the right justified mode. Or once you set it to the left justified mode, it sticks in that. The only one that doesn't stick is set W. Set W has to be called before every time you want to use it. That's why we had to do set W here, and it's why we had to do it again here. Because it only affects the very next thing that's coming. You can't just say I want all my numbers to be 10 digits wide, and so I'm going to set W10 at the very top of my program. No, you have to do it before every number you print out. Once you start getting it formatted, you got to do it if you care about its format. What's it doing?
Right here. And right here.
Yeah, what? Oh, two great. Two less thans, not one.
2 less than's?
Yeah, look at the cross.
Oh. Ah.
And a semicolon.
Oh.
I see what you did. You're going to make it so that that thing can count huge numbers. Yeah, what if you wanted to be able to double that number more than 30 times? If you double it more than 32 times, like if you double it 33 times, if you change that to while C is less than or equal to 33,
It's going to corrupt it.
it corrupts the data. And so I'm going to copy what you just did and make it a long, because you can see it got corrupted right there. So if I change X to be a long, that's the line that I changed, and that's the line that I changed. Now it supports larger data types.
Let me see if I can make that to 50.
Yeah, it seems like we played with that and figured out how large we could get it. I don't remember.
Yeah.
All right, so that's a form of while loop.
Oops.
This is a counter-controlled while loop. We just have a counter. It's going 1, 2, 3, 4, 5, 6, all the way up until we tell it to stop.
Yep.
I'm going to lower that down to 10 because I'm tired of seeing that many numbers on the screen. So as far as our I/O manipulators go, we have seen set W, which sets the width of the next piece of data. We've seen right and left, which control whether the data is right or left justified. And we've seen set precision, sets the precision, right, of the floating point to be displayed. Yeah, I know. It's kind of like, how could I word that better? And then I gave up.
Without getting all too technical.
Used with fixed, it sets the number of places after the decimal point. So, cout less than, fixed less than, set precision, parentheses 2, will display data in the x.xx format, which is nice for money. All right, last time I kept y'all here until 10, and that was too long. But as long as we're on the idea of loops, let's talk about the other kind of loops. At least one other kind of loops. This is one kind of loop. It's a counting loop. Another loop is called a sentinel value loop. What does sentinel mean? The sentinel is the sentry. It's the signal, right? You can't go into the castle without, without passing the sentry or, whatever. Here's an example of a sentinel loop.
Write this one too.
Please enter a score or -999 to quit, or -1 to quit, or something like that. Please enter a name or Q to quit. That'd be a bad choice because if you're a Star Trek fan and named your baby Q, then Q might really be, Anyways, so what is a sentinel value? Sentinel value is a value that marks the end of a series of data. Right. Enter test scores, followed by -1 to quit. It just marks the end of the series of data.
Do you do that after? Do you do that before the loop or at the loop?
Well, you're going to make it part of the loop. So let's calculate a total. So we're going to create a variable called total, and we're going to initialize it to 0. And we're just going to add up a whole bunch of test scores and calculate the average. So we need another variable that'll keep track of the number of tests number of scores that have been entered.
So while.
And that may as well be an int, because it's going to be a whole number, right? You've entered 1 score or 2 scores or 3 scores or whatever. So how about num underscore scores? Int space num underscore scores equals 0.
And colon.
All right, so let's ask for a score. We need a variable to hold our score. Double space score. Cout less than.
Double
Enter a test score. Colon space end quote semicolon. CIN greater than score semicolon.
Did you already do roll call?
Probably not. Good point. All right, and then, although when I miss it, I just take it based on who submits stuff, but I'd rather take it verbally. So let's do while parentheses score, and this is going to mean not equal to. Exclamation mark equal, while score not equal -1. No professor's as big a jerk as to give you a negative score. In parentheses, curly brace, num underscore scores plus plus, semicolon, total plus equals score, semicolon. So we've added 1 to the number of scores, right? So that after they've entered 4 test scores, the num scores equals 4. Each time they type in a score, it gets added in the total. And it's okay if this doesn't make perfect sense, but I'm betting that most of y'all had fundamentals, and so it is. Now we need to ask them again. Cout less than quote, enter another score or -1 to quit. Colon, space, end quote, semicolon. CIN greater than score. Now let's just print the average, or let's print the total and the average. We need to calculate the average. Well, the average is just a total divided by the number of scores. So, Cout less than. Wait, no, let's calculate it. Double space average equals total slash num underscore scores, semicolon, and then we can print them out. So Cout less than quote, total equals space end quote, less than, total less than ENDL. And Cout less than quote, average equals space end quote, average arrow average less than ENDL, semicolon. All right, so enter a test score, 50. Enter another score, -1 to quit, 100. Enter another score, 80, 70, and then -1 to quit. That's a sentinel loop. A sentinel loop is when you have a special value. That means I'm done. And so the total was 300 and the average was 75. All right, so there's the concept of BMI, which stands for body mass index. That's just a measure of how tall someone is as opposed to how much they weigh. So like if you went to a BMI calculator And
Google has one.
yeah. So if I said that I weighed 200 pounds and I was 6 feet 10, I'd be extraordinarily skinny and I'd have a BMI of 20.9. On the other hand, if I weighed 400 pounds and I was 4 feet 10, then my BM would be much higher. Okay, right. So who really cares about the numbers? But part of the assignment is going to be to implement that calculator. The formula is given to you, so it'll be pretty easy to do. And there's a different formula if you're going to do it in metric units. So if you feel like making it, ask for kilograms and centimeters, that's cool. So, body mass index. Ask the user for their weight in their pounds and their height in inches and calculate their BMI, body mass index. So the formula is BMI equals 703 times weight divided by POW, height, comma 2. In other words, height squared. And display the results. Make every variable a double. So an example. What is your weight in pounds? Say you type in 200. What is your height in inches? Say you type in 60. And then your calculated BMI is, now I'm going to cheat. I'm just going to go and run these numbers back in here. 60 inches is 5 feet, if I'm correct about that. All right, 39.1. Okay, so that's the way that needs to work. And then the miles per gallon calculator. I guess we're on a 3-letter acronym, quick kick. Ask the user for how many gallons the trip took and how many miles it was. Calculate the miles per gallon. MPG is equal to miles divided by gallons, right? If it took you 10 gallons to get there and you drove 100 miles, 100 miles divided by 10 gallons is 10 miles per gallon. And display the results. Make every variable a double. Go ahead and put them both in the same CPP file, and you can upload the source and a screenshot. Bonus credit, make the program ask what they want to do. Before it asks for data, have it ask, do 1 for BMI or 2 for MPG, and let the user make that choice. And then do task either 1 or 2. And you don't have to do that. Just blow that off if you don't want to. But if you feel like it, that'd be kind of neat. I'm sure you remember how to do if statements from your prior programming experience, so if you feel like doing it that way, that'd be cool. Are there any questions over that?
Can I have a printed copy of the homework on Notepad? Or?
Yeah, sure. I'm going to upload it as well. But yeah. So I'm just going to tack this on to the end of our... There we go. And let's make our Dropbox and stuff and be done for the day.